Hello, today I would like to give a short introduction about metal alloys and corrosion. First, a little bit about metal alloys. Materials react differently to heat due to which material alloys they consist of. Alloys are usually produced by melting a mixture of ingredients. This mixture will often give the new material increased strength or hardness. Metals are very rarely used in its pure form. Almost all the metals used for technical purposes are different alloys. By creating alloys, we can give materials new mechanical, physical, and chemical properties. A stainless steel alloy is primarily composed of iron and carbon, plus a small amount of chromium, which will give the metal its finish and superior corrosion resistance. There is different grades of stainless steel, which also is a mixture of different elements. Grade 304 stainless steel can contain up to 35% nickel. Grade 316 stainless steel contains molybdenum, a silvery white metal that is ductile and highly resistant to corrosion. Alloys 316 and 316L are both marine-grade steel. 316L has a lower proportion of carbon, which explains the L, which stands for low, behind the 316. The carbon cannot exceed 0.03%. This alloy is a better option for welding as it will reduce the tendency of the material to crack after welding, thus preventing corrosion. 316 stainless steel contains between 2 and 3% molybdenum, which increases resistance to corrosion, acidic elements, and high temperatures. Whether you should use 316 or 316L stainless steel, you should consider the following factors. Corrosion resistance. 316L contains less carbon than 316. It has better intergranular corrosion resistance, which means that its welds won't decay unlike with 316 stainless steel. Both alloys cost approximately the same. Magnetic properties. 316 stainless steel has a very low responsiveness to magnetic fields. 316L steel is susceptible to have some degree of magnetism. Practical application. Both alloys are used in a wide variety of industries. 316 is primarily used in construction and infrastructure because it is strong, resistant to pitting, and corrosion resistance in most circumstances. 316L is used for marine environments, pharmaceutical and photography environments because it can withstand welding and corrosive chemicals. When different materials is joined together by welding or screws, it is very important to take into account the material corrosion properties. Similar materials fit well together, different materials don't. When different materials come in contact with each other through a fluid, a galvanic corrosion occurs. Galvanic corrosion is when one of the metal is eaten by the other in a short timeline, while the other metal has no corrosion or has a very small corrosion compared to the other. In this picture, you see an example of what I just told you. You see here, the nuts are very corroded but the pipe and the flange is how quickly the victim metal rusts and how large the rust area which is rusting depends on 3 factors. The difference in voltage potential, the conductivity for the corrosive liquid, the relative size of the area which is in contact with each other. All metals has a voltage potential. Through research, various voltage potentials have been found for different metals in different fluids. The results are listed in a voltage range in a ranked order. In an electrical circuit, it is a metal which has the highest potential cathode, minus, and a metal with the lowest potential anode, plus. The current is floating from the cathode to the anode through the electrolyte fluid and back to the cathode. The corrosion will occur when the current leaves the anode and enters the electrolyte fluid. When different metals are in contact, it is the anode which corrodes and the cathode which is protected. And here you can see the galvanic series charge. The most anodic metals are on the top and the most cathodic metal is on the bottom. And the anodic metals are the one which is mostly likely to corrode. And the galvanic range shows the metal put in groups. The metal which is most anodic is the metal which is most corrosive. Here you see an example of different materials combined with a stainless steel screw and bolt. You see here's an aluminium plate. This is more anodic than the screw, so it will be attacked by corrosion under the screw, and it's also more anodic than the brass plate, so it is also attacked between the brass plate and the aluminium plate. And the brass plate is attacked by corrosion between the bolt and the plate. Some design rules to prevent corrosion. The area of contact between the metals has an influence on the speed and scale of a galvanic corrosion. When it is a threat to the function of the screws, it is necessary to do some considerations during the design phase. For example, you can avoid using different metals together. You can make a barrier between the components which is in contact to reduce or eliminate an electric circuit. You can insulate with organic non-conductive material, plastic, or even paint. You should make sure to design the product with drain options to allow fluids to drain out from the product and to prevent moisture from accumulating. The fastener used between the two materials should be a cathode, and the materials which is joined together should be anodes. Because it is very risky if the screw, which is the smallest piece, should rust and the function of the screw will disappear. And you should make sure that the area of the cathode is smaller than the area of the anode. An option is to use fewer screws with a higher strength. A metal coating is functioning very well until a damage in the coating occurs. If the coating is an anode, it will protect the metal it is covering, while a cathode cover invites to a corrosion attack on the underlying metal. If an organic coating is used, it is to prefer that both anode and cathode is covered. If only one of the metals can be covered, make sure it is the cathode. If possible, it can be installed victim anodes in the metal structure to protect the function of the main structure. It is very common to use this procedure in structures such as oil rigs and boats. Here you can see some example where they use victim anodes in the metal structure. Here's a large propel of a ship. They have placed several victim anodes here to protect the main structure. And the same in this picture, many victim anodes. These victim anodes can be attacked by corrosion, but it will protect the main structure and prevent it from corrosion. This was all I had for now. I hope you found it interesting, and I hope you will follow me in the next video. Bye bye.